Our objective for today, I can classify and evaluate polynomials according to degree and number of terms. Let's read it together. 1, 2, 3. I can classify and evaluate polynomials according to degree and number of terms. So today we start a new concept. That's why you do need your Frere model. And what would be the concept for today? Tell your neighbor, please. Very good. The concept is polynomials. Polynomials. That's what goes in the center of your Frere model, yes? Okay. So you write down your objective at the bottom left. Okay. And you write polynomials in the center of your Frere model. However, before I get to polynomials, I want to first break down one term that I need for this next piece, and it's monomials. You probably heard it before, and I just want to clarify and make sure that we all understand what they're looking at. Is everybody done with the objective? No. Okay, you got about 20 seconds. Go. So, before I start with polynomials, let me first define monomials. Pens down, eyes up here. Focus, please. It says, a monomial. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. Therefore, a monomial may be a constant or a variable. You don't have to copy this, just pay attention, please. Here it goes. Pay attention or you're going to miss this part, and I need this part for the definition of polynomials. Here he goes. It says monomial is a number. Okay? A number could be 23. Okay? Or a variable like Q. Yes? So, or it says a monomial could be the product of a number and variable. Product means multiplication, so it could be 23 times Q. Michael Jordan. Or, and then it says with whole number exponents. What does that mean? No negatives and no fractions. Everybody with me? Yeah. Okay, so now, let me show you what that looks like. Just pay attention, please. Here it goes. These are monomials. According to the definition, it could be a number. Let's see, is this a number? Yes. Okay. It could be a variable. Is this a variable? Yes. Okay. It could be the product, which means multiplying numbers and variables. Let's see, we got -7 multiplying x and y. Yeah, this is a monomial. Okay. And it says it could have a whole number exponent. Let's see, a number multiplying a variable with a whole number exponent. Yeah, that's a monomial. Are we there so far? Yeah. Okay, so now let me show you what is not a monomial. Okay, look at these. So, think about it. Why is this one not a monomial? Okay, tell your neighbor, please. Okay? So I heard it has a negative exponent. Is that correct? Yeah. So we cannot have negative exponents, okay? Let's see. This one right here is not because it's a fraction, but it's because it has a negative exponent. You're saying, where, Mr. Q? Where was x cubed before it became to the denominator? X to the -3. So this was a 2 times x to the -3. Can we have negative exponents? No. Okay. Now look at this one. By looking at it straightforward, it looks so simple that it might go by as a monomial, but look at the definition. It says numbers, variables, or the product of numbers and variables. So why is that not a monomial? Talk it over with your neighbor, please. Because of okay, so I heard because of the subtraction. That is true. According to the definition, it can have what? Product. What does product mean? Multiplication. Watch. This is multiplying. This is multiplying, but these right here are subtracting. So as soon as you see a subtraction or an addition of two different terms, then it's not a monomial. Are we there? So now that we know monomials, so let's define polynomials. Here we go. Polynomials. Write this down. Are monomials or sum or difference of monomials Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. Polynomials are monomials or sum or difference of monomials. If we look up, please. Here it goes. Pens down, eyes up here. It says, polynomials are monomials or sum or difference of monomials. So let's see. So that means polynomials could be a monomial. Yes? So watch. Example, the first one is 2. 2 is a monomial, right? That is also called a polynomial. This next one, x squared. Pay attention, please. Pens down. X squared is a monomial, yes? But it also is called a polynomial. But watch, as soon as we do this, as soon as I do x squared plus 2, because it says here monomials or sum or difference of monomials. What is happening here? The sum, is that correct? Am I adding two monomials? Yes, that's why this is also a polynomial. Or what if I did this? It's also a polynomial because we're doing what? Difference of monomials. Are we there? Copy that, please. So, let me show you some more examples. Look up, please. Look at this one. Negative 3x to the fourth plus 2. This is a monomial, this is a monomial, and there's a sum. That's why this is called a polynomial. Look at this one. Monomial, 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 and there's sum and difference. You guys see that? Yeah. So this is also a polynomial. Okay? So now, before you copy that, check this out. There's a certain name for each polynomial. And let me show you that. The name of each polynomial depends on the number of terms first. Watch. Right now I'm focusing on the number of terms. You're saying, what does that mean, Mr. Q? Well, that's what I'm going to explain. The word monomials can be broken down to two words. One word is mono, which means one. The other word within that same word is nomials, which means parts. So this one, monomial, means that it's got one part. Does everybody see that? Okay? Hold on. So a monomial has one part. Look at it. Here's one part. However, look at this one. Everybody look up. This one has three monomials. Does everybody see that? Okay? So when you were growing up and you were writing... you weren't able to ride a bike yet. You rode a tricycle because it has three wheels. If this one has three parts, therefore it's tri, and since these are called parts, it's nomial. Look at this one. Once you finish riding a tricycle, you went into a bicycle, which has two wheels. This one has two parts, so this is binomial. And we said these right here, these two are called what? Monomial. Copy that, please. Question. So now check this out. Notice that I only gave you these three examples: monomial, binomial, trinomial. After that, after you rode a tricycle, bicycle, and then you got on those motorcycles with four wheels, they're called what? Quads. But the next one would be called quadnomial. Sounds kind of weird, right? That's why any expression that has more than three terms, from now on, they're called polynomials. Because, check this out. The word polynomial, focus please. Poly means many. And we already know what nomials mean, right? Many what? Parts. And here, from this point forward, we're going to call the parts terms. Copy that, please. Poly means many. Nomials means parts, but from now on we're going to call them what? Terms. The parts we're going to call terms. The parts we're going to call terms. Okay? So, we got that defined. So now let me show you what some non-examples, so you can make sure we close our thought on polynomials. Here we go. Non-examples. Look at these. 2 equals 2x, copy that. X squared plus 3x plus 2 equals 0. And negative 3 plus x equals 10. Look at those. Think about it as you're writing them down. If these are polynomials, why do you think these are not polynomials? Okay, talk it over with your neighbor. Why are these not polynomials? Go. Okay. I heard you guys saying that because these have equal signs. So these are equations. If these are equations, these are expressions. These are equations, these are expressions. So the very first thing for polynomials is that they are expressions only and that they have various terms. Expressions only, various terms. Expressions only, various terms. Copy that. Okay? Copy these steps, please. Only 4 steps. Copy those. It says, number 1, identify the degree of each term of the polynomial. Step 2, arrange the terms of the expression from greatest to least degree and identify the leading coefficient. Step 3, classify the expression according to the greatest power and the number of terms. And step 4, evaluate and simplify. Copy those, and I'll tell you what to circle and underline. Go. All right, here we go. Circle the word identify, underline degree. For step 2, circle the word arrange, underline greatest to last degree. Circle the word identify and underline leading coefficient. For step 3, circle the word classify, and then you're going to underline greatest power and underline number of terms. So when we classify, when we name it, we're going to use those 2 things. And at the end, underline just evaluate and simplify. Okay? So basically, today we're going to do a couple things. Number 1, we're going to identify the degree of each polynomial. We're going to arrange it from greatest to least degree and identify the leading coefficient. From there, we're going to classify it, which means we're going to give it a name according to their power and the number of terms, evaluate and simplify. Are we there? Yeah. Okay, so with that said. So first, look at step 1. Step 1 says identify the degree. Pay attention, please. Identify the degree. How can we do that? Let me show you how to do that really quick. So earlier I showed you monomials, yes? And according to the definition, it says the degree of a monomial, pay attention to this part, the degree of a monomial is the sum of the exponents of the variables. The degree of the monomial is the sum of the exponents of the variables. What does the word sum mean? Addition. You're going to add the exponents of the variables. Are we there so far? Yeah. Okay, watch. I'm going to zoom in a little bit so that you can see the monomials. There they are. So it says we need to add the exponents of the variable. So watch. Look at this monomial. To find out the degree of this monomial, I need to know the exponents of the variables. What is the exponent here? How about here? So this is to the 2nd degree. This is a monomial to the 2nd degree. Are we there so far? Okay. How about, look at this one. How many variables do you see? Just one. What is the exponent? So this is fourth degree. To find the degree of monomial, you add the exponents of the variables. Look at this one. This is a monomial. What is the degree of this one? 1, because the exponent is 1. Look at this one. This is a monomial. What is the degree? 0. Why? Because it says find the sum of the exponents of the variables. Everybody understand? Now check this out. However, what if I gave you this one? Everybody look up. Now that you know, what is the degree of this next one? Let's see, 2 to the 7th, x to the 3rd. Tell your neighbor. What degree? What degree is this monomial? The correct answer is 3rd degree. Why didn't I add the 7? Because it says you need to add the exponents of the variables. Everybody understand? Okay, copy this next 3. Find me the degree of those monomials. Example 1a is 4p to the 4th, q to the 3rd. B is 7ed, and c is 3. I'll give you some time. Go. Okay, check with the neighbor, see what they got for the degree of those 3. Okay, this one is 7th degree, yes, because it's 4 plus 3, that gives us 7. This is to the 2nd degree, because 1 plus 1 is 2. And this one is to the 0 degree, because it doesn't have a variable. Hands if you got all 3. Okay, good. Copy these next 3. Good. Okay, here we go. Copy these. Example 1, D, E, and F. And for D is 1.5k squared m. For E we got 4x. And for F, 2c cubed. You got 1 minute. Go. Okay, here we go. This one. I know it's warm in here. Here we go. This one is 3rd degree. This one is 1st. And this one is 3rd. Hands if you got 3, 1, and 3. That is correct. Okay? So, now that we know how to identify, everybody look up. Look at first step. Identify the degree. Do we know how to identify the degree? Yes. But now I'm going to give you a polynomial with more parts, more terms. Okay? So copy this down, please. Example 2a. Write these instructions, please. It says, write the polynomial in standard form, then give the leading coefficient. I want you to underline as you write down standard form and leading coefficient. Focus on those words. And the polynomial that they give us is 6x minus 7x to the 5th plus 4x squared plus 9. Okay? Okay. Just copy it and then pens and pencils down. Now for this one, check this out. I'm going to do the first 2 steps of the steps that we wrote. The first one, it says identify the degree of each term, and second, arrange the terms of the expression from greatest to least, and then from there we're going to identify the leading coefficient. Because they're asking us 2 things. Everybody look up. They ask us to write it in standard form and also identify the leading coefficient. So pens down, writing utensils down, pay attention please. Here it goes. Step 1 says identify the degree of each term. Look up please. I'm going to start with this one. What is the degree of that one? 1. Okay. From there I'm going to go to the next one. What is the degree of that one? 5. Okay, so far so good. From there I go to the next one. What is the degree of that one? 2. And then the last one does not have a variable, so it's to the 0. Are we there so far? Okay, that was step 1. Okay. Step 2, though, it says arrange the terms. What does that mean? Arrange the parts of the expression, okay, from greatest to least degree. Do we have the degrees? Yes? Yes. Okay, so let me do that first. Everybody look up, please. Look at it. Which is the greatest degree? 5. So I'm going to write this term first. Negative 7x to the 5th. What would be my next term? This one. So I write plus 4x squared because we're going in descending order from 5 to 2. There it is. What would be the next degree? 1. So what is that term? Plus 6x. And my last term is plus 9. This is what we call standard form. Copy that, please. Okay, here we go. So check this out. Did we do the first step? Identify the degree of each term? Yes. Step 2, arrange the terms of the expression from greatest to least degree. Did we do up to right here? Yes. Yes, but look at the last part of this step 2. Identify the leading coefficient. Watch. This is how you do that. Everybody look up. The leading coefficient is the coefficient of the first term once it's in standard form. This is in standard form. What is my first term? This one. What is the coefficient? The word coefficient means the number multiplying the variable. So look at this. What number is multiplying the variable? Negative 7. So the leading coefficient is negative 7. Now, hold on before you write that down. What if I had this next one? Everybody look up. What if I had 3x squared plus 5x plus 6? What would be my leading coefficient? I go to the first term. What number is multiplying the variable? 3. That's my leading coefficient. This is my leading coefficient. What if I had this? Everybody look up, please. X squared plus 5x plus 6. What would be my leading coefficient? Pay careful with this one. My first term is this one, right? What number is multiplying x squared and invisible? So the leading coefficient will be 1. Everybody see that? Okay, copy this, please. If you want to copy these underneath so you can have it in an example, that's fine. Do that, please. Go. Okay. All right, copy this next one. Example 2b. You don't have to copy the words anymore, the instructions, because we already have them. So just write example 2b and write the polynomial y squared plus y to the 6 minus 3y. Let me zoom in for those of you that are back there. There you go. Write that in standard form and identify the leading coefficient. Go. All right, here we go. So, first you identify the degree. This is 2, this is 6, this is 1. So then you rearrange them. Y to the 6 plus y to the 2nd minus 3y. Hands if you did that. Okay? That's standard form. Remember that? And what is our leading coefficient? Invisible 1. Hands if you got that? Okay, good. Let's do one more. Yes?
Why is it 1? Like, isn't that like the smallest one?
Why is it 1? Because, remember, if we have y to the 6, or let me put it like this. Watch. What is, pay attention please, what is 1 times y?
1y?
Or y.
Oh, okay.
We no longer write the 1, but we know it's in there. Is that correct?
Yeah.
So therefore, if you have a leading coefficient, y to the 6 plus y squared minus 3y, what's the invisible leading coefficient here? 1. Copy this one. Example 2c. Let's see how you do with this one. This one is 16 minus 4x squared plus 5x, plus x to the 5th plus 9x cubed. Write it in standard form. Find me the leading coefficient, please. And I'll bring the steps to the front so you can have them there. Just remember, follow your steps. Okay, here we go. So first step, you need to identify the degree. This one is 0. This one is 2. This one is 5. This one is 3. So far, so good? okay? So, which is the greatest degree? The fifth. So I start with this one, x to the fifth. What's my next one? 9x cubed. What's my next one? Minus 4x squared. And what is my last term? Plus 16. Hands if you got that as standard form. That is correct. So, our leading coefficient is 1. Why? Because we look at the first term, and what is the invisible number there? 1. We got it? Alright, so basically right now we did the first two. Now let's classify. Watch. Let me show you how to classify. To classify, I made this table for you guys. Check this out. I made it up, by the way. Yeah. So check this out. We're going to give the polynomials a name using the degree. That's the first name that we're going to give it. And using the number of terms. We already know the number of terms. Monomial, binomial, trinomial, or polynomial. Are we there? Yes. So now watch. These are the names using degree, and these are the names using terms. But remember, the first name is according to the degree, and the last name is according to the term. Kind of like us, we have a first and a last name, right? So the first name has to be degree, the second one has to be term. So watch. Let me go back to the previous one. First of all, what is the degree? What is the highest degree on this one? 5. Okay, and how many terms does this one have? 4. So we're going to give it a name according to degree, which is 5, and the number of terms, which is 4. So watch. 5th degree and 4 terms. So the name of this polynomial is quintic polynomial. Did everybody understand? Yes. So you're going to take one of those tables. They're over here up front. And on your way out, make sure you turn in your sign party and your homework. And yeah, the party that I sent home, you needed to get that sign, right?
Oh, I didn't know that.
Yes, you did. I told you guys yesterday. Homework is found on page 489 to 490. Numbers 1 through 4, comma, 10. Oh, 9, 10, maybe. 9, 10, and then from 11 to 14. Yes, in your math book. Good one, guys. Enjoy your homework. See you guys to Monday.